thanks a lot for giving us the opportunity to present a little bit our journey with digital twins and in this case applied to infrastructure. So I'm Jesús Isoird, I'm Technology Manager at Tecnalia, business area on buildings and infrastructure. And let me check if I can go to the next slide. So I think that I have started the presentation even with conclusions. So for us, it was really relevant when we started this process to try to make smart decisions through smart data. And I think that this was one of the key elements that we discussed in the workshop this morning, because when we are talking about digital twins, we are talking most of the times about the complexity of which information do we need, which the data that is correct or not, and how we're going to extract valuable information to make decisions. So in this case, I'm going to talk a little bit about the inspection and maintenance work. We have been working for more than 30, 40 years in the field of structural inspection. We have mainly started to work in the digitalization process in bridges in the beginning. So we digitalized all the process on how to evaluate the structures, how to identify the damages, how to do an evaluation which is not subjective and is independent to the inspectors, and how we integrate it in bridge management tools and so on, right? But a couple of years ago, we were in front of a project which was the inspection of 40 kilometers of tunnels in one big highway, motorway in Guipúzcoa, in the north of Spain. And we say, oh, that's a challenge, because if you imagine that you have to do the inspection by foot, it means that you have to do usually during night, because you don't want to cut the traffic in high hours. And that means also quite risky for the people. So we did a pilot, well, a pilot under commas, because we proposed to our client to do in parallel, I would say, digitalization process, and in this case, try to use scanning technologies. One of the key points for us was to also understand the limits of technology, because now we can tell you that you can see many things, but not all. So we decided to work with a scanning system which was embarked in a vehicle. We decided not to do with fixed stations, also because that means to cut the traffic, and we didn't want. So we tried to find a compromise between precision and trying to disturb the minimum as possible with the traffic. Which, by the way, normally in train tunnels, you don't have this problem, because you can work during the night with no problems. So on the left, left, you have on the left, on the top, you have the point clouds, and below also we have the images of what we achieved. It was also a challenge to work with the lighting system, because in order to really be able to get the best images. And once we got it, also we integrated in a kind of GIS system, where we had all the inventory and we have all the life cycle data from the inventory, the inspection, the calendar of inspection, the reports and the models and so on. Here on the left, you can see also we did some testing of what you could see offsite, and then we had to go even to the tunnels when we identified some critical damages and try to confront the information. And we developed a system where the inspectors could go directly with the models. You have also a problem with the connectivity within the tunnels, but we solved it charging some low resolution models in the tablets, so they were able to pinpoint and to check the different damages. For us, was also very important to develop all the catalog of the damages that the inspector could find out on the field, because we wanted also to first be very fast, not to lose as much time as possible, and also to simplify a lot for them the process. In this case, they were integrating the data directly on the point clouds, and then we were able to extract it to the softwares that we were showing in the slide before. So then we jumped to the real time, because what you have seen before is static information. So you go to do the inspection, you enrich the models, you have the information, you treat it on site, and you have a kind of diagnosis or a study to manage an asset. This second step, what we worked was to incorporate real-time information of critical assets. In this case, it's a rail bridge that we are monitoring now. So we integrated the information from the sensors in an IFC model with visualization software that we have developed in Tecnalia. And then what we have done is to confront the data with structural models of the bridge. And then what we try to do is to define a profile of performance of this asset. We are working now in degradation models to see how is the evolution of the structure, and also to try to identify or to set some kind of alarms in case of there is a situation which can be risky for the structure. Now we are in the process to go through a third step, which is also very much aligned with the presentation of TNO before. So it's this combination of this cooperation between different digital twins. In this case, we are consolidating the work that we have done before in a kind of a living lab in the territory of Vizcaya, which is what we call Vizcaya Connector Corridor, where we have two verticals, one which is dedicated to cooperative and autonomous mobility, another one which is related to smart and safe infrastructure, where we are using the whole network of the roads of the region in order to provide testing and certification processes, research projects, working on some standards and regulation, and try to disseminate new technologies. And what we are developing is all the digital layer in order to be able to incorporate and to integrate the different data from the two verticals. And also we are testing different kind of visualization models, combining GIS and BIM in order to exploit all the information as best as possible. Finally, I wanted to give some quick pinpoints of Beeyonders project, because all the information that I have shown you before is more kind of commercial services that we are working. In this case, this is a European project that it just started a couple of months ago, which is called Beeyonders. And it's focused on the development of digital twins, more oriented to the construction processes of civil infrastructure. We are trying to integrate all real-time information from construction projects, in this case, based on the integration of data from machinery, could be autonomous or not, or teleoperated. We have some technologies related to additive manufacturing and 3D printing. The idea of incorporate also sensing systems into the workers and also integrating some exoskeletons to support also the performance of and the safety of the workers in the field. The idea is to integrate all this data into the digital twins and try to boost everything related to human-robot collaboration. So this is quite big consortia with different partners. But in terms of digital twin, we are starting now the work. This is coordinated, this part by Tecnalia and CSTV mainly, and we are going to work about all related to user requirements of the digital twin in this case, which are the workflows and data exchange that we need to implement in the working site. Also to define clearly which are the KPIs that we want to measure, how to capture the data, store it, and integrate it in the system. It's also quite important, the interface and the visualization, because we are thinking on the perspective of the construction project manager, who has to have the dashboard to control how the process is evolving. And of course, the idea is to integrate this with the BIM environment. And we are hoping to validate this in 6 pilots, which are quite different from each other. One which is dedicated to tunnel construction, where we are going to use autonomous machinery and drones to take information, real-time information on how the excavation and the tunneling process is performing. 2 pilots related to roads. One dedicated to construction, another one to maintenance. In this both case, working with autonomous robots. One example or one case study will be focused on maritime construction, in this case for the manufacturing of caissons and also using some 3D printing to manufacturing kind of reef shape elements. We have also a running collaboration with Japan, with specific company, which they have some autonomous machinery for piles, and we will have a testing case here, well, close to here in the port of Rotterdam, and finally we will have also a pilot in Finland related to building construction. And well, we hope that the next year we can come show you some results of this project. So thank you a lot.